For RCR Wireless News, I'm Sean Kinney, and I'd like to welcome you to today's webinar titled The Essential Role of Gigabit LTE and LTE Advanced Pro in a 5G World. This webinar was developed in partnership with Qualcomm Technologies, and today you'll be hearing from Rasmus Helberg, Senior Director of Technical Marketing, and Sunil Patil, Senior Director of Product Management, both of Qualcomm. In many ways, 5G is envisioned as a network of networks where a range of access technologies are combined into a single air interface, a sort of unifying connectivity fabric that will support a wide range of service requirements and use cases ranging from cellular-based IoT to mission-critical services like remote industrial control that absolutely require ultra-high capacity and incredibly low latency. But as the standardization work around 5G continues, many of the underlying technologies are taking shape today and providing very real impacts to increasingly advanced and innovative LTE networks around the world. The transition to Gigabit LTE networks based on the LTE Advanced Pro standard, then on to 5G networks, includes advancements in carrier aggregation, as well as advancements in bringing LTE into unlicensed spectrum, both with and without the presence of an anchor tenant deployed in licensed spectrum. Higher order modulation, like 256 QAM and beyond, combined with the evolution towards massive MIMO, marked by innovative 3D beamforming techniques and increasingly dense antenna arrays, is helping operators not only keep up with enterprise and consumer data demands, but truly deliver a cutting-edge user experience that gives us a glimpse of what 5G might look like. Taken as a whole, this technological evolution on the path to 5G is enabling new and better services for public safety, unmanned aerial systems, and even immersive digital TV experiences. LTE Advanced Pro is helping to perpetuate the booming Internet of Things space. It's driving connected car technology towards C2VX, along with many other exciting developments. And while we do see a huge buzz around 5G, it's important to remember that it won't be like flipping a light switch. Commercial 5G networks will coexist with these Gigabit LTE networks for years. Gigabit LTE will ensure a smooth 5G network rollout, and it will provide the wide area coverage and seamless mobility that users expect. We've set aside some time at the end of the presentations to take some questions. You'll be able to send those in to us throughout the webinar, so we look forward to an insightful exchange. With that, I'd like to thank you again for joining us and allow me to introduce Rasmus Helberg.
Great, thank you, Sean. So I will give you a quick introduction on the role of LTE and LTE Advanced in the 5G world. And then Sunil is going to focus a little bit more on the Gigabit LTE evolution. We're also going to see how LTE is expanding into new verticals, and then what is the role of 5G NR in this context. And we're going to wrap it up with the Q&A. So we already heard a little bit from Sean about the vision for 5G, a unifying connectivity fabric that can support much more than previous generation, more higher data rates and lower latency, also connecting new kind of industries, enable new services or use cases, empower new user experiences. But one important aspect of 5G and the whole platform is that it is actually a platform for future innovation as well. So one thing that is very interesting or different from previous generation is that we have this ability to support things that we haven't envisioned today. We have ability to support future services that not even dreamed up of. But initially, the focus is really on three main segments. We already heard about it: enhanced mobile broadband, mission critical, and massive Internet of Things. Obviously, you see the car in the middle, but that's a good example of actually a service that would need all of these enhancements, both enhanced broadband for entertainment and maybe for virtual reality in autonomous cars, mission critical aspects, like one thing we're going to talk about today is C-V2X, as well as support for low power communication from the massive Internet of Things. And one more thing about, before we go to the next slide, is, you know, when we talk about this unified and connectivity fabric, is really also the unification that we haven't seen as starting to happen in LTE, but we have the unification across spectrum bands and types, licensed, unlicensed, from low bands to high bands, up millimeter wave, diverse services and deployments. So one thing then is to enable this vision. We actually need LTE as the foundation to do that. There's also an aspect of certain services maybe not perfectly fit into this categorization, like voice and broadcast. We will hear about later that is examples of what LTE Advanced provides as essential services to the 5G platform. So 5G redefine a wide range of industries, and the importance of the platform aspect of 5G, especially with the 5G NR, the 5G new radio part that's being designed by 3GPP right now, is the ability, as I mentioned before, to connect new services more with more capacity, but also support these emerging and unforeseen services. And just to exemplify the impact of 5G, we did a study with a third-party entity to show what the economic impact would be. And you see one of the examples here in the slide on how much worth of goods and services we can see in 2035 by 5G in the range of $12 trillion. And if you want to learn more about that, you can go to our site on 5G economy study. So since we have a lot of topics to discuss, I'm not going to go into the use cases so much, but one thing that's interesting here that ties into the whole discussion is that this is a little bit different from when we went from 3G to 4G, because that was mainly about enhanced mobile broadband. And obviously that's very important to 5G, and also look into new dimensions like uniform experience and not only higher data rates. But what's different here is also that we are introducing new verticals with LTE and LTE Advanced Pro. So many of these examples we show on these slides are being targeted by LTE today and then will be enhanced by 5G NR. I mean, one example, for instance, is immersive experience. We'll hear about that later, that with Gigabit LTE, we can support better the immersive experience with virtual reality and augmented reality. But then if the capacity needs with many more users and increased quality, we need 5G for that, 5G NR. So LTE Advanced Pro is already, as I mentioned, is really a critical foundation for 5G. And we're going to give some examples of some of the essential services it provides from day one, and also this early expansion into new verticals. So this slide is really, to some extent, a summary of the presentation today. We will have a section, Sunil is going to talk about how Gigabit LTE is essential to the 5G mobile experiences, how it leverages the coverage of LTE, and also how it's evolving to become even more immersed or support even more capacity and even higher data rates. Then I'm going to go over the expansion into new verticals that LTE is doing already today. And that ties into what we discussed at the beginning. It's about connecting new industries and enabling new kind of service we haven't discussed before. We're going to focus more on IoT, cellular V2X, and a little bit on ultra-low latency that's been introduced, as well as drones and broadcast. So to be successful in the 5G world, it's very essential to have the foundational LTE coverage everywhere. And it's not only from a network deployment perspective, it's also from a technology evolution perspective. A lot of the innovations that's been happening in LTE is actually going into 5G NR in some shape or form. But obviously, the products that enable this is also critical. That's why Sunil is also going to talk a little bit more about the products that's enabling Gigabit LTE, and specifically the Snapdragon X16 model. So to continue the introduction on the essential services the 5G provides from day one, it's not an exclusive list, but I think this is a good example of some of the important examples. And one thing that is important to note here is that what is going on right now in 3GPP is that we have standardization of 5G NR, new radio. That is the new numerology that is being defined to support this new flexibility, and it's expected to go to a work item in March in the plenary, so that's quite soon. At the same time, when this work is going on, the plan is to to submit also LTE Advanced Pro together with the 5G new radio to meet the IMT 2020 requirements. So in essence, you need both LTE Advanced Pro and 5G NR new radio to meet the IMT 2020 requirements that lte-u is setting out to define 5G. So some of the examples of what we need is Gigabit LTE with LAA. Gigabit LTE provides the foundation for 5G experiences with multi-connectivity, leverage the coverage, good experience everywhere. LAA, license-assisted access, is very important for many regions where it's not enough access to licensed spectrum to get the Gigabit LTE, so that globalizes really the Gigabit LTE opportunity. Another almost forgotten aspect is obviously we have to support voice. So VoLTE, we have spent many years to optimize the refined, and we have a really good solution. That's going to be the voice solution for day one. Obviously, eventually, there's going to be a voice solution in 5G NR as well, but that's not going to happen day one. LTE IoT is the same. That is really going to start to connect the massive IoT already this year, ahead of further optimized 5G NR massive IoT. And one aspect of that is also that the initial part of the standardization for RIS 15 for NR is not going to focus on massive IoT. So that means that this is going to be the IoT solution, cellular IoT solution for years to come. The fourth aspect is cellular vehicle-to-vehicle communication, also called C-V2X. And that was standardized in at least part of it, the V2V part of it, last year, and established the foundation for safety use cases. And it will be expanded gradually in future releases to do complementary safety use cases. And trials will actually start already this year. And we have announced trials with partners, and we'll more on that later. The fifth area that's interesting here is ultra-low latency. Ultra-low latency too is interesting both for enhanced broadband, we will see that later in the discussion, but also as a precursor to the more mission-critical services where you have low latency communication for command and control, etc. That's already happening in LTE. They'll also call other critical services for 5G day one, that's digital TV, public safety, and drone communication. So before we go into this section to discuss the first area of critical services, Gigabit LTE, as well want to give you some updates on some recent updates and the progress, because this is happening today. And the first example is the world's first Gigabit LTE device launch and network launch that you probably heard about last week with Telstra. More on that by Sunil. Massive IoT is already starting to connect with the broad industry adoption of Cat M1 and Cat narrowband 1. We have secured a lot of wins, and Cat M1 is already commercial, and Cat NB1 is getting commercial. And we mentioned this C-V2X trial starting already this year. And the fourth one is something we don't really have so much time in this webinar to discuss, but we discussed a little bit that LAA is really an effort to, or a key component to globalize a Gigabit LTE deployment, especially when an operator doesn't have enough spectrum to leverage, to get to enough spectrum to support Gigabit LTE speeds by using unlicensed spectrum. And this is something that is going to be important this year also for the Gigabit LTE launches. But it has another dimension that is also pioneering new spectrum sharing paradigms that could be used to evolve even further in 5G. You can do, when you start from scratch and support unlicensed spectrum, we can do more than we've done today, and we can actually do things in the sharing area that are even better than we can do in LTE. So this is sort of one example also how we're pioneering things in LTE Advanced Pro, and it could be even be better done in LTE, in 5G NR. So with that, we go over to the next section to discuss the Gigabit evolution.
Thank you, Rasmus. So, so in the next section, we'll talk about how, what is enabling gigabit per second LTE. What are the key features that are coming up in LTE, and how this will this sets the stage for even significant enhancements that are coming up in 5G. So Gigabit LTE is kind of the first step towards kind of 5G mobile experience. Even as recently as a year ago, or even it was difficult to imagine to be able to have a smartphone that can support gigabit per second data rate. But this has become a reality, and I'll share a little bit more on the product support, in next few slides. But effectively, having such high data rates is going to enable, VR and AR types of applications. In parallel to these LTE evolution, even on the application processor side, there's significant advances happening. That the smartphones are now capable of supporting AR, VR applications. These very high data rates would also enable fiber-like connectivity, so that the data will be available instantly. So that so this information can be stored in cloud and can be made available instantly over LTE. Very high rich entertainment requiring very high bit rate could be supported, as well as instant apps. In future it may not be required or to download all the apps on your phone. Because of the fast connectivity, it would be possible to achieve that that level of experience without really requiring to download your application. So again, I think Gigabit LTE will enable new frontiers, new applications that are also supported. As I mentioned, even though the application processor side, there is evolution happening, progress is happening, and kind of these two are very complementary. Now, 5G mobile experience requires ubiquitous gigabit per second speed, and there are if you look at the technologies that typically we use on our smartphone, wireless technologies, both are actually evolving to support such high data rates. So on Wi-Fi side, there is AC, AX, or even AD, which enables gigabit speed in local areas. And as I mentioned, even on LTE side, especially in 2017, we will see products that support gigabit per second LTE, which effectively will provide, will extend the coverage of gigabit speed beyond just local areas. And then this sets the stage for even multi-gigabit per second technologies like 5G NR, which will mainly be deployed in kind of two sets of spectrums above 6 gigahertz and below 6 gigahertz. So 5G NR will further elevate mobile experience. And I think, as Rasmus said, there will be applications that we cannot even foresee today, but the capabilities of 5G NR will really unleash those applications, and we'll talk more about that later. Now, how is it possible to achieve gigabit LTE or even more than gigabits in future? So there are really three key dimensions here. You can, carrier aggregation has been a key LTE feature. Over the years, the number of carriers that can be aggregated has increased. This year we expect even up to four carrier aggregation. Another dimension is MIMO. Of course, basic LTE already supports 2x2 MIMO, but the innovations both on the baseband side, on the RF front-end side, as well as ability of the commercial OEMs to be able to design 4 antennas will also allow 4x4 MIMO devices, or has already allowed smartphones with 4x4 MIMO capabilities. And another dimension is higher order modulation, which is 256 QAM. So with these enhancements, a single stream in LTE can support 100 megabits per second. And as you add more carriers, more 4x4 MIMO, as you can imagine, one can keep adding the number of streams, and that would allow to achieve very high data rates of gigabit per second and even beyond. Qualcomm has already announced our Snapdragon X16 LTE modem, which is category 16 and is capable of achieving 1 gigabit per second of peak data rate. So in 2017, this is gigabit per second is actually a commercial reality, and we expect this evolution of LTE to continue to achieve even higher data rates in future. Now, one of the key enablers for these high data rates or gigabit per second LTE is LTE in unlicensed, or the 3GPP feature that refers to this as LAA. And one of the reasons for that is, of course, to be able to achieve high data rate, operators or carriers need spectrum. Now, not all carriers have large amount of spectrum, or even if they do have it, it could be very fragmented. And I think that's where really LAA comes in and offers an opportunity for carriers to be able to achieve very high data rate. So this could be 5 gigahertz, or it could be shared spectrum in 3.5 gigahertz as well. And so effectively, together with capabilities that I already mentioned earlier, like 256 QAM and 4x4 MIMO, the large amount of spectrum that can be utilized in unlicensed spectrum would allow carriers to achieve these very high data rates. In fact, we expect carriers to commercially launch LAA in 2017. We've already announced our capability to support this on our Snapdragon X16 modem. And it has been discussed very widely so far, but now it's proven, it's accepted by standard bodies that LAA with its capability for listen before talk is a fair neighbor of Wi-Fi. In fact, overall it actually improves performance in unlicensed spectrum, and even FCC has granted the equipment certification for deploying LAA in 5 gigahertz. So again, I think we believe it's a very important step in evolution of LTE, and it really offers carriers an opportunity to offer the very high data rate or gigabit LTE experience. Just to kind of recap, so in late last year, Qualcomm announced X16 LTE modem. This is the world's first gigabit class LTE modem, and in fact, since then there have been we've also announced our smartphone chipset, which is SD835, and this smartphone chipset takes advantage of this X16 LTE modem. So not only we actually announced a Netgear commercial product that uses this X16 LTE modem and is able to achieve gigabit per second. We made this announcement together with Telstra and also our partner Ericsson. And in addition to that, as I mentioned at CES, we announced our premium tier smartphone chipset, which is a SD835, which actually has integrated X16 modem together with leading application processor, and this SD835 we expect will enable gigabit per second capable smartphones, in 2017. By mid this year, we hope to see, or we expect to see, gigabit per second capable smartphones. Now, we discussed, so there are, several dimensions in which LTE is continuing to evolve. We discussed about carrier aggregation, as, there is very strong desire from carriers to continue to aggregate their spectrum to achieve even higher data rate and also to achieve efficiency in their network. Higher order modulation, there is already carriers have commercially deployed this, to take advantage of higher link efficiency. LA will see commercial deployments in 2017. In addition to that, CGPP is also standardizing. So the deployments in 2017 will really be in downlink. But then there is already standardization happening to also enable uplink in LTE unlicensed, or also referred to as enhanced LAA. This will further, improve capacity available to the carriers. A couple of more dimensions that we'll discuss. One is kind of evolution to support massive MIMO, which allows 3D beamforming, and there is also significant effort happening in 3GPP to reduce the round trip time, or to reduce latency. This is referred to as ultra low latency, which effectively would not only improve throughput because it reduces the round trip time, but it almost gives real time experience to the applications that really rely on real time or very short round trip time will be enabled with this ultra low latency. And I'll talk a little bit more in next few slides. So ULL, or ultra low latency, are improvements proposed in release 14 and beyond release 14. And really the objective is to reduce the latency into as low as 1 millisecond on LTE. And how does this help? So this, reducing latency really helps with the performance, especially of TCP protocols. It allows you to achieve even higher throughput, better user experience for real-time applications, because now you have such a short round trip time. Overall, the applications that rely on feedback from the other entity or the client, those application performance would improve significantly. And it also paves the path for mission critical services. Having lower latency, high reliability, further expands the areas or the applications where LTE can be used now. Now, how is this actually achieved? So if you look at the LTE frame structure today, the smallest, or really the smallest time interval in LTE is referred to as the transmission time interval. It is 1 millisecond in duration, and it has 14 OFDM symbols. Each one is 70 microseconds. Now, the goal for the standards team is really to reduce the TTI so that there will be even fewer symbols. So it could be 7, 4, or even 2. And when you reduce the number of symbols in tte-i, that of course effectively reduces the tte-i duration itself. So for example, with 2 symbol tte-i, the tte-i duration would be 140 microseconds. Now, what this results in is, so effectively this helps us reduce the round trip time. So if you take an example of 2 symbol tte-i, so on the right side of the slide, there is an example. So for FDD, if when data is sent in tte-i 0, typically it takes about additional 3 tte-i's to process and acknowledge, and another 3 tte-i's to receive the acknowledgement. So effectively, in about 6 or so tte-i's, it will be possible to receive the acknowledgement and be able to send the next data again, continue with the data transmission. So what that means is effectively the hybrid ARQ round trip time is approximately 1 millisecond. And again, this will be a huge improvement on, today the transmission time interval itself is 1 millisecond. If we are able to, if the round trip time itself we are able to reduce to 1 millisecond, that will be a huge improvement in, reducing the latency on LTE. And as I mentioned earlier, this will enable new real-time applications, mission-critical applications, also help increase the throughput. Even on TDD side, the goal is to reduce the round trip time, by shortening the TTIs, so that TDD ecosystem can also take advantage of, shorter round trip times. Other dimension that I briefly mentioned is also massive MIMO. What massive MIMO effectively will allow is also beam forming in both elevation beam forming as well as azimuth beam forming. So effectively it will be possible, so we will be able to exploit 3D beam forming using just 2D antenna arrays. And what that results in is, as shown on the chart on the right-hand side, which as you increase the dimensions of MIMO, going from as you increase the number of transmit antennas going from 8 to 16 to 13, this will allow to really exploit or be able to generate more beams and take advantage of massive MIMO. And this would really improve the both average user throughput as well as cell edge throughput. And there is good progress already happening in 3GPP. So release 13 has new code books for 8, 12, 16 antenna ports, and release 14 is further enhancing, to support up to 32 antenna ports, with further enhancements planned for release 15 and beyond. Now, all this sets the stage for even further enhancements in 5G. And so what 5G will allow is be able to take advantage of new spectrum technologies. So there will be new spectrum in millimeter wave, that 5G will be able to take advantage of to, offer even higher data rates. This will further, so this higher data rates because of availability of wider bandwidth. So this will further improve performance, efficiency, and as well as such high spectrum, such high frequencies will also be able to allow to take advantage of more antennas and beam forming. But some of these technologies will also be available in sub-6 gigahertz, especially in the range from 3.5 to 4.8 gigahertz. Those frequencies will, we expect will also be available for 5G to take advantage of these new 5G technologies. So in effect, 5G NR will take mobile broadband to the next level. There will be new TDD, FDD designs, for shorter latencies. There are new techniques such as self-contained subframe, scalable TTI. We'll talk about that a little bit later. Massive MIMO. There are new advanced channel coding such as LDTC codes, which will further improve efficiency of 5G system. There are new techniques to reduce overhead. And I mentioned millimeter wave, which will trigger a lot of innovation and also make available new spectrum to 5G to take advantage of, especially allowing wider bandwidth, and also more efficient use of shared spectrum will be achievable with 5G NR. And so with that, I'll hand over back to Rasmus to talk about new mobile ecosystems that will be enabled by 5G.
So now you learn that to be successful in the 5G era, we need both ubiquitous Gigabit LTE coverage everywhere, and that's going to be better, as well as 5G NR for new spectrum, millimeter wave, as well as in sub-6 GHz for wide area coverage, and around 3 GHz, as well as in low bands like 600, 700 US and Europe. And there's a benefit for this new design that can drive down cost efficiency and performance thanks to the new design. But one key aspect also of this new platform 5G NR is the ability to flexibly support different kinds of services, as well as having this ability to support unknown future service. And that's very different from the past, where we sort of added service onto LTE, and it's not always been possible. So that's why we also have the opportunity with 5G NR to start in release 15 with enhanced broadband, some of the mission critical, but not all services at the same time. So I will focus then on how LTE Advanced Pro then expanding the mobile ecosystem to date, some of these new verticals that also is the focus of this 5G NR. And if you look at this evolution, it's pretty interesting. We had the voice and data service for a very long time, and then we sort of almost have an explosion of expansion into new verticals, new other things. Automotive service, M2M, public safety, new spectrum types we heard about, digital broadcasting and mission critical services that we also discussed. And it's interesting here too that, I mean, obviously we list automotive services, one aspect that will need vehicle-to-vehicle communication, but that's a good example of a service that actually needs both data services, maybe also mission critical services, as well as M2M IoT services with the narrowband IoT and IoT. Another good example of enhancements in the LTE advanced evolution, we already heard about ultra-low latency, could be helpful for ultra-low for mission critical, but also as well as for data services, as we heard. So let's go into some of these verticals in more detail. So we don't have time to go over all of them, but we're going to focus then on C-V2X, IoT, and on digital broadcasting. So we start with IoT. LTE IoT started connecting massive IoT in 2017, and it's going to be a key 5G service pillar ahead of 5G NR massive IoT. And as I mentioned, 5G NR release 15 is really focused on enhanced broadband. So LTE IoT is the solution to connect the massive IoT, and it's happening now. We have a lot of enhanced or announcements on Cat M1 already being deployed, as well as upcoming narrowband IoT. And we are doing that in our combined solution, MDM9206, that supports both modes in a single SKU for cost efficiency. Since we want to get to the questions, I will not go so much into the details here. I think we have a lot of information on our website, and we had webinars on these topics. But I think one important thing is to understand there's an evolution going forward, and eMTC in narrowband IoT is really scaling down complexity, power consumption, and range. But we are, for instance, narrowband IoT is scaling down to tens of kilobits per second. eMTC scales up to 1 megabit per second, and it's in 1.4 megahertz spectrum. Narrowband IoT is in 200 kilohertz. But what we do in Release 14 and Plus and beyond is that we're scaling up performance on eMMTC, so you can cover even 5 megahertz or beyond to support high data rates, enhancing services. But we're also scaling down in complexity even further. So narrowband IoT can go even lower in transmit power and energy-related reduction, as well as enhancing some of the functions that you see in the middle. CV2X is a very important feature for the autonomous car of the future. It is one component of multiple sensors that will be there. Obviously, you will have LiDAR, you will have cameras, you will have ultrasonic sensors, but CV2X is an additional sensor that goes beyond line of sight to get additional information to improve the safety. And that is already started in Release 14. It was actually completed last year, where we have this V2X component. So that is vehicle to something component. So the V2V is vehicle to vehicle. So we're using specific assigned spectrum. It's called the so-called lte-a spectrum around 5.9 gigahertz. So you don't need a network per se here. You don't need a mobile network to run this safety application. The cars are communicating directly with each other, as well as with pedestrian or infrastructure. If you look at the left side too, we see also we have the network components. There's a benefit to also to leverage the mobile network to communicate for more situational awareness. For instance, if an accident is 2 miles ahead, then you can broadcast that to all users versus communicating shorter range directly between cars. And this evolution is going to continue. Release 15 is going to add complementary capabilities such as sensor sharing, so you can share information from the car ahead of you. It can be more capacity, wider bandwidth, so you can send more data. So there's a lot of exciting additional use cases that's being discussed for Release 15 and beyond. And this is happening. I said the initial specs were already completed last year, but brought in the support with the 5G AA and Automotive Association is driving vehicle communication, as where CV2X is an important part. And I think they already have around 30 members, where Qualcomm is part of it, obviously. And we also mentioned before that trials are starting in second half of this year, and more trials on the pipeline. Cellular drone communication is also a key thing we want to cover, and I think what we are doing here is unique in the sense that we have a test area that's very close to a military airbase. So we had to communicate with the flight controllers to do any flight tests, as well as it has a mix of industrial and commercial enterprise deployment, as well as a canyon. So you can get a good mix of different environment to really test the performance of the drones. And what we're doing initially is really to optimize LTE networks. And what's surprising here maybe is that even though the antennas are down tilted, it works very well up in the air. So what happens is you just see more antennas. Oh, sorry, you see more base stations when you go up. Like at the ground, maybe you see 3 base stations, go up 200 feet and you see maybe 20. So we have verified this up to 400 feet, then it works fine. But we're still looking into then what kind of optimizations you can do beyond this. And we can also bring some of this into the standards, as well as drive regulators, especially to get beyond visual line of sight operation that's not possible today or allowed. And also accelerate the 5G deployment. Since we are a little bit, we have a little bit less time than expected, I skip EMBMS, but it's a big effort for digital TV in Europe, strong candidate. You can look at the slides later on. And obviously, when we go beyond to 5G NR, we'll continue to the expansion into new verticals and can deliver even better efficiencies and new capabilities from Release 15 Plus. And we discussed, we're going to discuss the roadmap soon, Sunil is going to do, but some of the enhancements for mission critical is going to happen in Release 15 and beyond, like ultra low latency, the reliability is coming in as well. Most of the massive IoT enhancements for 5G NR is coming later, Release 16 Plus, but as we said, really is the IoT solution in Cat M1 and narrowband IoT that's going to be the main solutions for IoT in the meantime. So with that, we are going to then hear how 5G NR is fitting into this equation, because we're saying that we are really evolving LTE Advanced Pro, and it's covering a lot of new verticals. It's an essential part of the 5G platform. So where and what is when is 5G NR needed, and what does it really do beyond what LTE Advanced does? And one key aspect is the flexibility to support unknown services, a platform for future innovation. Let's hear more about that.
Yeah. So, we've talked. I mean, there's a lot of talk in the industry about 5G. I think the point we want to stress is, we're not just talking, but we are actually creating it. We are making it possible in two ways, in some sense. So I think I already discussed about LTE Advanced and gigabit per second and all the new features that are being, Qualcomm is not. Some of them are already commercial in our product, like gigabit per second LTE, and some other, and even eMCC or nb-iot, LAA. But then I think there are some other features like ULL, V2X, ELAA. Right now, we are working, very closely with our ecosystem partners and trying to get those standardized in 3GPP. And we are also working with our partners very closely on 5G NR as well. Trying to really take NR or 5G NR at a different level, even compared to LTE. Even like ultra reliability, low latency, multi-gigabit per second, also unlicensed in NR. So again, I think that we are really trying to make 5G as well as LTE Advanced technologies kind of commercialize those as well, and standardize as well as commercialize. Now in standards, even before I get to standards, late last year, Qualcomm was the first one to announce a 5G chipset, which is X50. It supports millimeter wave, 28 gigahertz. Right now, it supports Verizon 5G spec as well as KT6 specs. Those are the only ones, kind of the pre-5G specs that are out there. But we are also working very closely with our partners and ecosystem partners in 3GPP, trying to accelerate 5G NR standardization, which will also allow, so effectively, if we are able to accelerate completion of some aspects of 5G, like non-standalone aspects of 5G NR in 3GPP to complete by end of 2017, this will actually allow 5G NR release 15 based 5G NR launches, 2019, 2020 timeframe. So that is work that is currently ongoing in 3GPP, and we hope to have decision on that, sometime in March. Now, some of we expect these early 5G NR deployments will be based on NSA or non-standalone architecture. And in fact, this would allow these early 5G launches. And effectively what this will mean is we will have the 5G new radio, the new RAN, together with LTE core network. So LTE EPC with 5G NR, and then of course LTE RAN providing as an anchor. So this would really allow faster deployment of 5G NR, and it will allow very nice transition and a very cost-effective way for also carriers to deploy the first 5G NR network. Now, in terms of the 5G frame structure itself, I guess the industry has learned a lot from LTE, and as a result of that, the goal is going to be to come up with a very flexible framework which will make it forward compatible for even services that are not known today. What that means is scalable TTI for scalable latency, integrated kind of the same integrated framework that allows multiple services like eMBB with very high data rate, device-to-device communication, or even multicast. Have very innovative design for self-contained integrated subframes, which will again allow lower latencies. Have built-in support for very efficient mission-critical transmissions, and also more flexibility in uplink downlink. Have very dynamic uplink downlink configuration as well. And on top of that, there will also be some blank subcarriers for new for services that I think we haven't foreseen at this time. But again, the goal is to have a very flexible frame structure and really take the lessons we've learned from LTE and apply those to 5G NR. Now, as I mentioned earlier, Qualcomm is working very hard, working with the ecosystem partners to really bring end-to-end approach, system approach to make 5G a reality. So we have best-in-class 5G prototype systems, test bed that we're working with our key partners. We are working in 3GPP to introduce new innovations, new features. Working with network operators on trials. Lessons of those trials will really help design better 5G NR. And as I mentioned earlier, we've already announced kind of the first modem and RF front end, for 28 gigahertz, which we believe not just us, but the industry will be able to leverage to be able to launch first 5G NR product. So kind of in summary, we covered, how we talked about LTE Advanced Pro and effectively how the innovations that are happening in LTE, such as LAA, voice over LTE, narrowband IoT, cellular V2X, and even ultra low latency that's being discussed in the standard, kind of sets the stage for 5G NR. So some of these services we're talking for 5G will be possible with these LTE Advanced Pro features, and then 5G will take it to even new level. With multi-gigabit per second data rates, it will really elevate the broadband experience. Rasmus talked about new verticals, the new services that will be possible through a very efficient frame structure and through very efficient, network design. And we expect there will be even further optimizations for massive IoT. So again, I think those will be built into the system design itself, which will make it, these transitions or these new verticals, new services to be enabled much more efficiently in future. So with that, we will like to conclude the presentation section of this webinar, and we'll address some questions we've received so far.
Yes, we've gotten a lot of great questions from the webinar participants, so thank you for that. We'll try to address as many as we can in the time remaining. First up, is 5G expected to outright replace 4G or live alongside it?
So I think we showed here that a lot of essential services from LTE and LTE Advanced Pro is going to live alongside for 5G NR in the end. And when we define 5G as per the IMT 2020 definitions, it's really a combination of LTE Advanced Pro and 5G NR, the new radio, will be needed to meet all its requirements. And you saw also the phasing of some functionality in 5G NR means that 5G or LTE Advanced Pro has a bigger role to play this time in this transition when we have expansion into this new IoT verticals and C-V2X and so forth.
We also had some interest on the relationship between 5G and fiber to the home. Is the goal with 5G to displace the need for these fiber to the home or fiber to the premise deployments?
Yeah, that's definitely one of the kind of use cases. In fact, I think some carriers, I think Verizon, for example, has been very public about it, that they want to be able to use 5G. I think even AT&T has now said this publicly, that they want to be able to deliver content into the home, really using 5G technologies. And one reason that's possible is we have the spectrum in millimeter wave where large bandwidths are available. And so definitely the technology will allow that. And you could also argue that the first steps of that are already happening. I mean, LTE already will support gigabit per second this year, and we expect even LTE to evolve. So yes, that is definitely a possibility with even with 5G.
You mentioned use cases. Another one of our webinar participants wants to know, what are the use cases that absolutely require 5G? And given what we can do with LTE, why is the business case going to be better with 5G?
Okay, so let's take one example. There's multiple examples, but let's do one specific. Obviously, 5G NR is also looking into reducing cost and power efficiency and overall efficiency, especially when you leverage new wider spectrum. But if you look at one example, like virtual and augmented reality, that is definitely possible today with good quality on LTE and Gigabit LTE, and that was one of the use cases we showed. But when you get a lot more users, for instance, that's going to use that, imagine autonomous cars and people are using it while computing, you need more capacity to do that. As well as the other dimension that's really driving virtual and augmented reality is the desire to get better quality. When you have, for instance, 6 degrees of freedom, when you want to move around and just not moving from a fixed position, actually move left, right, and so forth, then you need more data. And then the data rate, for instance, for virtual reality could go to gigabit speeds, gigabit per second, depending on the latency in the network, versus less than 100 today. Depends on obviously quality and but that's one example where you need it if you go to these massive use as well as increased quality.
Another one of our participants would like to know, from a policy perspective, what do regulators need to do to prepare for and support 5G and the Internet of Things?
Okay, yeah, so that effort is already ongoing. So I mean, it's an effort from in the US where FCC allocated or identified a lot of spectrum, for instance, in the 600 megahertz as well as in low bands, as well as in high bands in around 28 gigabits, as well as up to around 60 and 70, to free up more spectrum, make it available for more broadband. So that effort is happening already around the globe. Similar efforts in Europe, where we have identified spectrums like 700 megahertz in low bands, as well as mid-band spectrum around 3.4 and that we mentioned in the slide, as well as higher spectrum bands around I think 26 or 27 gigahertz. So we have covered both the low and medium and high bands. So that effort is going, and there's also a harmonization going on in trying to have global bands in the different regions. And you see some bands that's sticking out sort of here, and that is around 28 gigahertz. That's happening in US and a little bit lower in Europe and Korea, and as well as the spectrum around 3.4 or 3 gigahertz, as well as some regions are looking into a little bit higher bands around 4 gigahertz, as well as these low bands that I mentioned around 600 and 700. So that's sort of at least initial bands that's being considered.
We also got a few questions regarding the X16 LTE modem. If you could tell us a little bit more about the band support and perhaps offer a roadmap on availability of devices that will support Gigabit LTE.
Yeah, sure. So in terms of band supports, I mean, it supports pretty much all bands that are standardized in 3GPP. There may be a couple of exceptions. I mean, there's some bands have just been auctioned this year, or still under the plans for deployment are not clear. I mean, those would be 600 or band 14. But apart from that, pretty much all the bands that carriers have deployed worldwide are supported by X16 modem. In terms of commercial devices, so in fact, there was an event just last week in Australia on gigabit per second, where Netgear announced their gigabit per second. This is a MiFi device, so it's a gigabit per second device using X16 modem. So there are already commercial products, at least one that has been announced. And over next 3 to 4 months, or 3 to 6 months, we expect even both MiFi devices as well as some even smartphones to be announced.
And as we reach the end of our time, I'm going to ask one final question here. Building on your discussion earlier around the first gigabit LTE network launch in Australia, what's the outlook for commercial gigabit LTE in the rest of the world?
So I think the outlook actually is very positive, and so I think there are two aspects. So there are some carriers that do have spectrum to achieve gigabit per second. So you'll see more announcements. Even in North America, some carriers, at least one carrier, has been very public about it. And then even the ability of this modem to support LAA will, in our view, will further allow even more carriers to achieve gigabit per second. So I think, kind of to summarize, expect more carriers and device launches that are gigabit per second capable, rest of this year.
All right. Well, I want to thank all of our participants that join us on the webinar for these great questions. And particular thanks to our presenters from Qualcomm, Rasmus Elberg and Sunil Patil. And as a reminder, we will be distributing a link to a recording of the webinar following the conclusion. Thank you again for your participation.